Hi guys, this is Sean. Welcome to my YouTube channel, Data Science with Ishan. Today we'll be doing Machine Learning 103, which is about logistic regression. This is the data set that I got from the UC Arvin repository. You can download it over there. It has 11 attributes, out of which the last attribute, which is the class, is what we're going to classify. Yeah, and 1902 samples. That's a big data set. These are a few imports and a little code that I had something to start out with. So what I've done here is I've turned all the G's and the H's, which are gammas and hadrons, into ones and zeros respectively, because that'll help us classify our model much better. Okay, so it's time to make the sigmoid function. The sigmoid function is actually a S-shaped function. It keeps all the values of its input within the range of 0 and 1. So the actual formula for it is 1 divided by 1 plus the exponential value of minus z, which is actually a coefficient in linear regression or in, well, any kind of regression. So it's kind of it's a little hefty, but it's pretty easy if you try to read about it a little. So here I'm scaling my data set. I'm making my chaining in input vectors and output labels. So I'm fairly new to machine learning, and this all seems very exciting to me. I hope you guys are enjoying as well. I hope you support, like, comment, subscribe. It'll be wonderful and it'll make me so happy. And I'm just enjoying myself making these videos. I do it for you guys, but then again, it helps me learn and it helps me get better at what I do. I am fairly new to computer science, to be very honest. It's only been a year or so since I have been into any sort of computer science. I started programming in 2021, and yeah, it's been a rocky ride since. Yeah, I'm still very slow though. I'm taking so long to make this function. So basically, what happens in logistic regression is that you take any value and it will turn it into a value that is in between 1 and 0. So what that will do is help us classify whether a value is probably 1 or probably 0. That depends on our threshold. A threshold is something that we apply to our function that basically tells us, okay, anything over this part of the threshold is this or classified as this entity, and anything that is over the threshold is this entity or this characteristic, or this classified as this entity. So what we're going to do is we're going to take the logistic regression values, and basically what the model does is it takes the y hat, the prediction, and it checks whether it is more than the threshold, that is 0.5. If it is anywhere more than 0.5, then it's a 1, a gamma. Whereas if it is anywhere less than or equal to 0.5, it is most likely in hadron. So, yeah. Okay, so I'm applying the sigmoid function. See, I don't really know if that's a necessity. I really feel like sklearn library provides a module for that the input vector will have sigmoid values when the training is done. But this is just something I'm experimenting with, so don't mind. And especially here, I do see only sigmoid values. So I think it works, but let's see. Let's see if it works in the future. So I think we should make a model now. Oh, I had messed up the indexing. Wonderful. Yeah, yeah, they're all pretty much a little here and there, but that's why I'm going to try it both ways just to see whether it works. We're creating a model, we're calling logistic regression. I had already made the import initially, if you've seen. The import is from sklearn.linear model with a underscore import logistic regression in one go. L and R capital. And now we fit the data. Okay, so increase the number of iterations. Knew that. It's too many samples. So it's 300,000. That's what I'm going to do. Okay, there's still some scaling issue. So you know what? Let's just remove the sigmoid application part. I feel like the logistic regression module is going to do it for me. So I think we should do that. Let's make our predictions now. Training data, not testing data. I can't wait for the classification report, to be honest. It's really what drives me. It tells me how good my model is doing, what tweaks I have to make, how I can make it better. And it's just so much fun exploring the different ways that I can optimize my algorithm. Now it's time to see the accuracy classification report time. Yes. There's going to be a big formatted print statement. I must say I'm really slow. I have to get so much faster at programming. No one's going to hire me like this. Something wrong as usual. Yeah, I think everything is right. It's just from the indentation had an issue. Okay, so this is our classification report. So for the training data, it is fairly alright for 1. For 0, it is 0. That is bad. This is without applying the sigmoid function ourselves manually. Oh no, this is so much better. 0.73, 0.88 for 1, a 0.85 weighted average, a good recall. So now what I think we should do a little theoreticals. So logistic regression is a statistical model used for binary classification, which basically predicts categorical dependent variable based on various input variables. This is the formula for that. I'm moving too fast. I feel like I covered all of it in the video, but you can have a look at this text if you have any confusions otherwise. There are a lot of applications of binary classification or logistic regression, and they're being used practically everywhere. You know, like customer card for fraud transactions, and yeah, basically credit risk assessment, disease diagnosis. These are some very very integral applications of this algorithm. So I hope you enjoyed this video. Please like, subscribe, and share, and always keep hoping for more and more content because I'm enjoying having this YouTube channel. Thank you.